Bismillahirrahmanirrahim. Today I wanted to talk about the domain and range of a function. If you recall, I suggested before that if you had two sets of numbers like this, and if they were related like this, 1 going to 0, 2 going to 7, and 3 going to -5, you could call the first set of numbers the input and the second set of numbers the output. Or you could call the first set of numbers x and the second set of numbers as y. And finally, you could call the first set of numbers the domain and the second set of numbers as the range. In other words, these three numbers over here, in this case, they would be the input, the x, or the domain, and these three numbers over here would be the output, the y, or the range. Now, if there was a rule that took this 1 to 0 and 2 to 7 and 3 to -5, that rule would be called a function. In this case, I just kind of made those numbers up. But here, the x value represents the input, and the f of x value here represents the output. Or all the possible x values would be the domain, and all the possible y values would be the range. We can call this y or f of x like this. Now, just like my example, where it's a tiny function where the domain is only like 3 things, there are a lot of numbers that are not in here. That is, there are a lot of numbers that are not in the domain. For example, 0 is not, square root of 5 is not, pi is not, etc. And similarly, there are a lot of numbers that are not in the range over here. So clearly, for relations like these and functions over here, the domain and the range does not necessarily have to include all of the real numbers. Now, the way I see the domain is all possible x values, and the way I see the range is all possible y values. For this particular function, the parabola over here, there's no restriction on domain. In other words, x could be anything. X could be 0, x could be 1, x could be 3, x could be a billion, x could be -5, x could be -10. There's no specific restrictions for the domain. But for the range, the y value is slightly different. See, y could be 5, for example, right here. When y is 5, this would be the corresponding x value, or this one on this side, right here. But y can never be, for example, like -5, because there's no corresponding function value. Now, this is a very important concept to understand. So if you bear with me, I want to try explaining it to you. Pretend right here, there was a tiny little ant right here, and y equals to 5 over here. There was a tiny ant, ants like insects. And this tiny little ant wanted to kind of crawl across this Cartesian plane. It can only go horizontal. So what it wants to do is, it wants to go from here to over here like this. That's what the ant wants to do. Now, we're going to pretend, for the purpose of this demonstration, that this function over here is kind of like a river. Now, if you know anything about ants, ants don't like water. So when this tiny little ant comes over here at the river, it can't cross the river, so it's going to have to take a little boat over here. So it's going to start over here, come across the river, and then across the river, it's going to take the boat and go across like this. And then keep going, keep going, keep going, keep going. And then it's going to hit the river again, right? So I can take the boat again and then cross the river like this. So this ant is going to cross this river in 2 places, right here, when the x is over here like this, and at this x value over here like this. Okay. Now imagine another ant right here at y equals 3 level, like at this level right here. Now it wants to do the same thing. It wants to cross the Cartesian plane. Okay, so here it goes. Goes over here, comes across the river, takes the ferry boat, keeps going, and then comes across the river again, takes the ferry boat, and it's there. Scot-free. So this ant will cross the river at these 2 spots, whatever these x values are over here. It's going to cross the river there and cross the river there. In other words, there are 2 possible x values where y is going to be 3. Okay, now there's another ant right here. It's kind of like right over here on the x-axis when y is 0 right here. So that one's going to go over here like this. Go, cross the river right there, and then take the ferry boat, cross over there, keep going until it gets the reverse again. Take the boat and get across over here. So this ant crosses the river in two spots as well. And these are special spots. That's like the x-intercepts of the function, right? So we can call this one like S1, and you can call this one like S2. We got two more ants to go, okay? So here it is. At y equals -2. Now this ant starts over here and does one of these things. Keep going, keep going, keep going, keep going, keep going. And then it comes to the river over here. Takes the ferry boat, get across, and that's it. It only has the river at one spot, right? Now how about this ant over here at y equals -5, right there at this level? Well, that one's going to start over here and keeps going, keeps going, keeps going, keeps going, keeps going, all the way across, and lo and behold, there's no river in the way. So this is kind of like the happiest ant. It says, no water, I don't have to worry about my water phobia. Now, if these ants would all get together, now this one over here would say, you know, I came all the way across this Cartesian lane, and man, there are two places we have to take the ferry boat, right here and right over here. And this one would say the same. Well, I took the ferry boat over there and the ferry boat over here. And the other one says, oh yeah, I took the ferry boat right there and I took the ferry boat there. But you know what? These spots are kind of special in the river. They're like the x-intercepts of the river. You know what I'm saying? Now this ant goes kind of puzzled. What do you mean you crossed the river like 2 times? You know, I went straight across the Cartesian plane just like you guys, but I only crossed the river at one place. And then this ant over here is kind of like saying, hey, what river? What are you guys talking about? There was no river. Of course, this ant, see, did not cross the function, did not cross the river. In fact, if there were any ants beyond the vertex over here, none of them would actually see the function, right? None of them would see the river. They would not have to cross the river at all, because the function's minimum value is this. There's no y value beyond this that the function uses. So what this means is that the domain of this function, that is all possible x values, there's no restrictions for the x values. That means domain is all real numbers. There's no restrictions for x value. But the range, on the other hand, which is all possible y values, is restricted. Y is only from here up to there, see? These y values over here, beyond this vertex over here, they're not used. And in our function, these ants will never see any of these y's, because those y values are not used for this function. So the range here is restricted. The range here is y must be greater than or equal to -2. The vertex here is -1 and -2. Okay, so how about for this function? What do you think? What do you think is the domain? Now remember again, domain is all possible x values. Are there any restrictions to this function in regards to the x values? No, right? Because it's a parabola and there's no restrictions. So domain here again will be all real numbers. Now how about the range? Can y be any values? No, right? Because y cannot be anything beyond this, right? Like over here. The vertex here is 2, 9. So the only y values are in this direction, from 9 and below. So the range of this function, f of x, will be less than or equal to 9, because y values, the function values, do not go beyond that 9. So the domain will be all real numbers, and the range will be restricted to f of x is equal to less than or equal to 9. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.